classification where the output classes are binary in nature. They are either yes or no. In this one, we are going to discuss multiclass classification. For example, when you're trying to predict which party a person is going to vote for, the possible outcomes are one of these three. The concrete problem that we're going to solve today is to recognize the handwritten digit. For example, here this one maps to one of the output categories, which is nothing but digits 0 to 9. Similarly, here 4 maps to this particular output category. So we will use a training set with a lot of hand digit characters, and then we'll build a model using logistic regression. And at the end of the tutorial, you will have an interesting exercise to work on. So let's jump straight into writing the code. As usual, I'm going to use my Jupyter notebook as an IDE, and here I have imported matplotlib and also scikit-learn's dataset. So sklearn.dataset has some predefined ready-made datasets that you can use to learn machine learning. From this, I am using load digits dataset. So if you read the documentation, all it is 1797 handwritten digits of size 8 by 8. Okay, so it looks something like this. And what we are going to do is, given these digits, we are going to identify that what digit that is. All right, so let me just run it. So this has run fine. I am going to now call load digits method to load my training set basically, and I want to explore what this training set contains. So it contains a couple of things. It has data, which is your real data. So let's print few elements. So as it's written in the documentation, there are 1797 sample. So I'm just going to print the first one. And it's an array, okay? As such, it is an 8 by 8 image, but the image is represented as a one-dimensional array. So if you count these elements, it will be 64, which is 8 by 8. And if you want to see this particular element, then you can use matplotlib. So I'm going to do plot plt.gray, and plt has a method called matshow, and what you can do is you can print the corresponding image. So data has the numeric data, and images will have the actual images. So you can see that data 0 and image 0, they kind of relate to each other, and the only difference between the two is that you have numeric data here versus you have an actual image. So if you want to print, let's say first 5 sample, then you can just print it like this, and you will see that 0 1 2 3 4. Okay, and corresponding numbers will be in this data array. So that looks pretty straightforward. Now what we're going to do is use this to train our model. Now before we do that, let's take a look at target and target names. Okay, so our target, so if I print digits.target 0, let me print 0 to 5. So you see, like 0 to 5 is literally in a sequence. The first element is 0 1 2 3, and that's what this is printing here. It is saying that this image is 0, the last image, this is 4. So this is our complete training set, which has our image as well as the target variable, you know, like it says what it is. So we can use data and target to train our model. Now before training our model, the usual thing that we do is we import from model selection, we import train taste split, and we try to divide our data set into training and test samples. So the way you do it is you say xtrain, xtest. I don't exactly remember the order of the argument, so I'm going to do it. Okay, let me do this. So train test split digits.data, because that's your data set. Then you have digits.target, because that's your target variable. Okay, and if you hit shift tab, it will show you all the nice documentation of that API. So here it says this is the order in which it returns the output. All right, so now what I just did by executing this command is I had input and output variable from my training set, and I divided them into test and train sets. Now the reason that we do this typically is we don't want to overfit our model. We don't want to make our model such that we just bias it against the training data. That's why the data that the model is trained against should be different than the data that the model is tested against. Okay, so that's why we split these two. So if you look at, okay, I have to supply the size. So I'm going to probably supply test size. So I want 20% of my samples to be test size and 80% to be the training. Okay, so if I look at length of xtrain, it is this, and if I look at length of xtest, it is this. So this is roughly 80% of all available samples. All right, so I have a training and test data set split. Now I can create my logistic regression model. So from this, I want to import logistic regression and create a model object so that you can train it later. And you all know the way you train it is by calling a fit method. And fit method, you will call it against xtrain, and ytrain. When you run that, the model is getting trained using this xtrain and ytrain dataset. So again, to repeat, xtrain has the hand written characters, and ytrain will have the corresponding output. It will say, okay, for this image, it is 4, etc. Now, since my model is ready, the first thing I always do is I calculate the score. So the score tells you how accurate is your model. And the way you do that is you have to supply xtest and ytest. So using the xtest, it will calculate the y predicted value, and it will compare those y predicted value against the real value, which is ytest. Turns out that my model is doing pretty good. The accuracy is 96.67% almost, which is really good. So now I'm going to make my actual prediction, and you know that you have to call predict method for that. Now let's see. So before I call this method, what I want to do is I want to pick up a random sample. So I will say plt.matchshow digits.images. Let's say I'm just picking up a random sample. Okay, this is pretty hard. Even I don't know what this number is actually. Let's see. So this number is actually digits.target 67. So you have to access the same index in your target. Okay, so this is 6. Okay, so let's see what our model will predict for this guy. So I will say model.predict. Okay, model.predict what? Okay, what do I want to predict? I want to predict. Now see, I'm not going to supply images here because Image is all binary data. My model likes numeric data more, so I will use the same index 67, but I'm using data instead of images. Okay, this is the error you get when you're not supplying multi-dimensional array. So I'm just going to supply multi-dimensional array just for the sake of it. And you can see that it is predicting the target variable. All right. Okay, let's just, okay, let me just create a new cell here and let me predict. Okay, what do I want to predict? Okay, I want to predict 0 to 5. Now, you all know 0 to 5 is literally 0 to 5. So 0 is 0, 1 is 1, and so on. When executed, see, my model is doing pretty good. So my score is 0.96. How do I know where it didn't do well? Okay, because all the samples I tried seems to be doing pretty well. So I want to know where exactly it failed, and I want to get overall feeling of my model's accuracy. And one of the ways of doing that is confusion matrix. So I will show you what confusion matrix is really. For that, I have to import from this matrix. I need to import confusion matrix. Okay, and then before I do that, I need to get the predicted values. So I will say predict x test. When I run that, I get all the predicted values for this x test. Okay, and then I create a confusion matrix, and in the confusion matrix, what you supply is y test, which is the truth, and then y predicted, which is what your model predicted, and then you get confusion matrix back. When you run that, you get this 2 by 2 dimensional array, and you are wondering what the heck this is. So this is better visualized in Matplotlib or Seaborn, right? So I will use that library for the visualization here. I'm just going to copy paste the code for confusion matrix visualization. Here I'm using Seaborn library, which is similar to Matplotlib. It's used for visualization, and I'm calling a heat map here with the confusion matrix CM variable that we created here. And when you run that, this is the confusion matrix that you got. Now the way this works is, see here you see 37 number. What it means is 37 times the truth was 0 and my model predicted it to be 0. Here this 2 means 2 times my truth was 8, meaning I fed my model the image of 8, but my model said no, it is 1. So these are the instances where it's not doing good. So you can see that in anywhere in this area and this area, when you don't see 0, it means your model is not working right. So here, for example, again, 2 times my images were of digit 4, but my model predicted it to be 1. So that's what this is. So confusion matrix is just a nice way of visualizing how well your model is doing. All right, now it's the time for exercise. Today's exercise is going to be using sklearn datasets iris flower dataset, which has following 4 features. So if you don't know about iris is a type of flower, and the flower has a two type of leaves. One leaf is called sepal, the other one is called petal, and they have like a height and width, and based on these height and widths you can predict what kind of iris flower it is. Okay, so our data set will have 3 kind of flowers. These are the names of 3 different iris flowers, and the features that we have are these 4, which is basically petal width and height and sepal width and height. And you will use this dataset, the iris dataset, and you will load all those 150 samples. then divide them into test and training samples, and then build a logistic regression model and tell me the accuracy that you can come up with, and then you can just do a few predictions using that model. All right, that's all I had for this tutorial. I have the link of this Jupyter notebook down below, and you can find the exercise also, so make sure to refer to those